Okay, all right, it's running now. Y'all go ahead and let me have your attention. We're getting into chapter 4 today. And what we're doing is we're getting into triangles and triangle relationships. Chapter 4.1, the very first section, what we're going to be doing is we're classifying triangles. And we're going to be classifying them, first of all, according to the lengths of their sides. But let's first of all get a definition for triangle in here, okay? A triangle, a figure formed by 3 segments. Joining 3 non-collinear points, okay? Now it's important that we say 3 non-collinear points, because if they're collinear points, you're not going to get a triangle, you're going to get a straight line, right? So what we have here in the classification of triangles, we have something called an equilateral triangle. Okay, so the 3 types of triangles we've got equilateral triangle, isosceles triangle, and scalene triangle. Now, with an equilateral triangle, you've got 3 congruent sides, and so that just means each side of an equilateral triangle is going to have the same measure. Okay, we would indicate that equality of measure with a single hash mark across each of the 3 sides that indicates the congruence of those sides. An isosceles triangle, all right, a little bit different, is defined as a triangle that has at least 2 sides congruent. I'm going to use double hash marks here just so that you can see the different relationship and the sides between. I don't want you to confuse equilateral and isosceles. I don't want to try to intimate that I think the side of an isosceles triangle is equal to the size of an equilateral triangle here in this diagram. So the definition for equilateral, 3 sides congruent. Over here at isosceles, at least 2 sides congruent. Okay, that means you could have all 3 sides congruent. What this means is every equilateral triangle, by definition, could also be categorized as an isosceles triangle, but not all isosceles are equilateral. Okay? An equilateral triangle would be a special type of isosceles triangle where not just 2 but 3 sides are congruent. There's a little bit of overlap there. Scalene triangle simply means this. All right? No 2 sides congruent. Or you can think of it, all sides have a different measure. Okay, so all sides have different measures. So this might be an example of what a scalene triangle would look like. All right? There are no congruent sides on here. All sides would have a different measure. So there's not going to be any hash marks there. There shouldn't be, because that just won't be the case. So if I've got a triangle that looks like this, and again, don't go by the looks. Go by what's given to you. And I'm telling you that all 3 sides measure 8 units long. What type of a triangle would you classify this as? Equilateral, okay? But it's also, what if I had this? What would that be? Isosceles, okay? Now, if we had something like this, kind of going loosely by what's in the book here. And imagine that it's a good triangle, not the other one that you're looking at. 10, 7, 6. What's its classification? Scalene, right? Okay, good. So you've got that. That's a scalene triangle. Okay. Now, another way that we can classify triangles, the first way is by the sides and their relationships to each other. The second way to classify triangles is by their angle measures. If I have what's called an equiangular triangle, that's your symbol for triangle, I'll be using that instead of spelling the word out, and you may do the same thing. Then what you have here is a triangle where all 3 angles are equal, hence equiangular triangle, all right? An acute triangle is a triangle that's classified as such because all three angles measure less than 90 degrees, okay? All three angles measure less than 90 degrees. So let's say if this angle measure was about 35, this one would be about, well, let's say it was about 80 degrees, right? And the last measure would be possibly, let me look. Okay, your last measure would measure maybe 65 degrees, okay? This would be an example of an acute triangle, all right? I'll let you know soon enough, maybe not today, why I had to stop and think about what the three measures might be able to be. They have to add up to a certain number. But as you can see here, all three angles are less than 90 degrees, so it's an acute angle. Now, a right triangle is a triangle that has one right angle in it. You can't have a triangle with two right angles, and more on that later. Just know this. You've got one angle that has one right angle in it. You'll see that little box indicated, in this case, lower left-hand corner, indicating that this is a right triangle. Now, an obtuse triangle, anybody want to take a shot at what they think an obtuse triangle might look like? Or why it's defined as such? One angle measures. What's an obtuse angle? It's over 90, but less than 180. Okay. So you've got an obtuse one might look something like this. Okay. Where you have one angle here, and that would be this one right here, where I just put the check mark, measures greater than 90 degrees. All right, anywhere up from 90 up to, but not including 180. Could be 179, but it cannot be 180. All right. So that would be what we mean by an obtuse triangle. Okay, now in these three triangles that I drew up here on the board, what I want you to do here with me, let's classify these triangles by their angle measures and by their sides, okay? So when I look at this first triangle right here, it has two angles that measure 70 degrees. It's got an angle that measures 40 degrees. I've indicated two sides here are congruent. First thing, let's do this. According to the sides, the lengths of the sides, what can we say the classification of this triangle would be? So remember back here,
That would be
isosceles,
yes,
right? Remember back there, so you have isosceles. So we come down here, and I would call this, I'm going to use that abbreviation for isosceles. Now, what about the angle measures? How would I classify this by angle measures? And remember this. Classification by angle measures is different from sides. You're looking at the sizes of the angles in here. What can we say about all three of those angle measures? They're less than 90. So your types of triangles by angle measures can be categorized as acute, right, obtuse, or equiangular. You've got four ways to classify by angle measures, three ways by side, okay? You've got equilateral for sides, isosceles, and scalene. Equilateral means all sides congruent, isosceles means at least two sides, and scalene means no two sides congruent. So I'm looking at this, and I'm seeing all three acute angles. So this is isosceles, acute. Okay? What about over here? Right? Scalene, okay? Because no three sides are congruent. Right? So you've got a right triangle, and it's also scalene. Right? Smart board's not really working too well on that, but y'all can hear my voice on that. Scalene. Down here, what can I say about this triangle right here? This is a 95-degree angle.
that would be scalene.
Scalene would be one of the sides, and obtuse would be the angle measure. So we would say obtuse, and then Scalene, right? Okay, good. Okay, let's get another couple of concepts down here before we move on. In talking about triangles, when we talk about a triangle, it's we could say another thing about a triangle. Another way to think about it, it has 3 vertices and 3 sides, okay? Vertices, that's plural for the word vertex. So what do we mean by the word vertex? Like vertex of an angle? That's the place where the 2 rays, the 2 lines come together to form the angle, right? So a vertex, a point that joins 2 sides of the triangle. A point that joins 2 sides of the triangle, okay? All right? Now, we often speak of the side opposite from the angle. It's referred to as the opposite side. That is the opposite side, right? Get my smart board worked on. Software's not working for me too good here. All right, so if I have a triangle here, I'm going to call this A, B, C. All right? If I were to refer to the side opposite of angle B, what side would I be talking about here? It would be side AC. Okay? Because then here's your angle. The side opposite would be AC. So side opposite AC. So what side is opposite? Let's see, angle A. Yeah, you see that? It would be side BC. Remorse, that makes sense? Good. Okay. BC. That is an equal sign. Weird equal sign. Okay. What about angle C? Let's see, Charlie Bass. What side would be opposite angle C?
That'd be 80.
Yep. All right. Simple concepts, but you need to keep up with this. All right. Now, let me see where else we need to go to from here. Okay, I'm going to go ahead and put your assignment. I'll put it on RenWeb, and I'm going to go ahead and put it on this recording too. Your assignment, this is what we're going to go. It's going to get into section 4.2. I think I want to do something else. I'm going to first we'll give you your homework assignment. You can start working on that now. Page 175. Page 175 to 177. I want us to do 1 through 36 here. Okay? You know better than that too. Even or odds. You know these don't take that long to do. But also, also want you to do this because I think some of you need the algebra practice.
Yes, I do.
Page 178. 67 through 72.
Yeah, I need the extra algebra practice. I'm terrible at it. 67 through 72. They'll give you a little bit of practice on the algebra. We'll keep it right there, okay?